So we are continuing with our back. And here we go. So we'll start out with mental arithmetic, and we have to recall the cubes as we're building up to knowing 20 cubed off by heart. So last time 10 cubed is 1000, 11 cubed is 1331, 12 cubed is 1728, 13 cubed is 2197, 14 cubed is 2744, 15 cubed is 3375. Forwards, now without the pegs, 1000, 1331, 1728, 2187, 2744, 3375. And now by digits: 1331, 1728, 2197, 2744, 3375. And now backwards: 15 cubed is 3375, 14 cubed is 2744, 13 cubed is 2197, right? 12 cubed is 1728, 11 cubed is 1331. Without hooks: 3375, 2744, 2187, 1728, 1331. And by digits: 3375, 2744, 2187, 1728, 1331. And we begin the second cluster. So 16 cubed, 4096, 4096. And now 17 cubed. So 17 squared is 289. And 17 times 300 is 5100. And 17 times 11 is 187. So 5100 take 187. It's 4913. 4913. So 4096, 4913. 4913. And now 18 cubed. 18 cubed. So 18 squared is 324. 18 squared is 324. Now we double that, we get 628. And then we have to multiply it by 9. 628 times 9. 5652. 5652. So we think that it's 5652, but we have to check another way. So what we're going to do is we're going to multiply it by 20 and then take away 2. So 324 times 20 is 6,280. And then you have to take away 600. No, it's not. It's 6,480. And then you have to take away 648. 648. So we get 5832. 5832. Okay. All right, so we're going to try it again. 6280. No, 6480. 6480. Take 648. Yeah, 5832. 5832. All right, so 5,832. 1,832. 5832. 5832. And now we have to try 19 cubed. So 19 times 19 is 361. 361. Now multiply that by 19. So 19 times 300 is 5,700. 19 times 6 is 114. So 5,700 plus 114 is 5,814. 5,814 plus 19. 5,833. Okay. Next up, okay, we're going to try Quen. (47 times 53). 2,491. 47 times 54. 2,538. 96 times 104. 9,984. 213 times 187. 39,831. 9,987 times 10,013. Okay, so 10,000 squared is 100 million. And now subtract 169 and you get 99,999,831. 73 squared take 27 squared. This is the same as 73 plus 27 times 73 take 73 take 27 is 46. So it's 4,600. 148 squared take 52 squared. It's the same logic. So it'll be 200 multiplied by 96. Is it 96? Yeah, 96. 200 times 96, which is 19,800. 19,200. 19,200. 73 squared take 26 squared. 73 squared take 26 squared. So 73 squared is 5,329. 5,329. Squared, 676. So 5,329 take 700 is 4,629. Plus 24 is 4,653. 512 squared take 488 squared. So that's 1,000 times 24, 24,000. 30,002 squared take 29,998 squared. All right, that's 60,000, take away 4. 60,000 squared, take away 4. And when you square 60,000, you get, let's see here, 3,600,000,000. So 3,600,000,000, take away 4, is 3,599,999,996. Next up, square 97, 9,409. Square 1,006, 1,012,036. Square 993. Well, that would be 986,049. Square 10,004. 10,004. Right, that's 100,080,016. Square 9,995. Okay. $9,995. Nine squared is 81. 99 squared is 9,801. 999 squared is 9,999 squared is what? 3 9s, 1 8, 3 zeros, and a 1. So you have to take away 10 from that. Three 9s and a 0. No. Wrong. Fine. Yeah, 3 9s and a 0. 3 9s and a 0, 2 zeros and a 25. So 99,900,025. 48 squared, 2,304. 53 squared, 2,800. Alright, that's 38,809. 504 squared, 244,016. 2,498 squared. 2,498 squared. Yeah. All right. Well, that's the same as 2,500 times 2,496, and then plus 4. And 2,500 times 2,496. Well, what you can do is multiply the first by 4 to get 10,000 and divide the second by 4. To get 624. So it would be 6,240,000. And then you have to add 4. So 6,240,004. All right, so we'll just see if we can now move on to the JMC stuff. Because we've done 80 so far. And we want to, no, we've done 85. I want to reach 100. Given that 8 kilometers is roughly 5 miles, which of the following is closest to 1.2 kilometers? 0.75, or 1, or 1.2, or 1.6, or 1.9 miles. Okay, so 8 kilometers is roughly 5 miles, and that means 1.6 kilometers is roughly 1 mile, and 1.2 kilometers is 3/4 of 1.6. So the answer is 0.75. So we were asked, or rather we were told, that 8 kilometers is approximately 5 miles. And then we were asked which of these distances is closest to 1.2 kilometers. And we were given 0.75, 1, 1.2, 1.6, and 1.9. And we decided 0.75. distinct positive integers p, q, r, and s satisfy this relationship. 9 take p times 9 take q times 9 take r times 9 take s is equal to 9. So what is p plus q plus r plus s? Okay, so they cannot all be positive. Or rather, all the factors cannot be positive. That's impossible. Oh, I know. We need to have 1 times 3 times minus 3 times minus 1. And the way that we can get that is we set P, Q, R, and S to be, well, actually, we're going to do it in descending order. So 3, 1, -1, and -3. So we're going to set P, Q, R, and S to be 6, 8, 10, and 12. 6, 8, 10, and 12. And those add up to 36. 36. So we were told that P, Q, R, and S are 4 distinct positive integers, and that 9 take P times 9 take Q times 9 take R times 9 take S is 9. And we were asked what their sum was, and we believe the answer is 36. Which of a week, a year, a decade, a century, or a millennium is closest to 562,500 minutes? All right, so there are 1,440 minutes in a day, and in a week that would be 10,800. 10,800 minutes in a week. And in a year, that would be nearly that amount. So the answer is a year. So we were asked which of the following a week, a year, a month, a decade, or a millennium is closest to 525,600 minutes. And we believe the answer is a year. How many finishing orders exist for 4 runners if at most 2 can tie in a position? So if there are no ties, we have 24. If they tie for first, we have 12. Same logic goes for the others. So 24 and 36 for that. But then a pair could tie for first and a pair could tie for second. And there's 3 ways for that to happen. So we end up with 24 and 36 at 3, which ends up being 63. So in a 4-person race, and we're asked how many finishing orders there can be for 4 runners, and at most 2 people can tie, we believe the answer is 63. Again. Joe is 36 years old in 2024. In which of the following years is her age next a square number? And the years are 2025, 2037, 2047, 2052, and 2060. Is that right? Hello? Yeah, that's right. So 2025 would be 1 more year. 2037 would be 13 more years. And then she'd be 49. So that's valid. 2047 would be 28 more years, which is also valid. And 2060 would be 36 more years. So there's only two possible answers. 2037 and 2052. And now set 10. Evaluate the sum of evens between 1 and 101 minus the sum of odds between 1 and 100. So 2 and we would pair 2 with 1 and 4 with 3 and 6 with 5. And we'd carry on until we paired 100 with 99. And there are 50 pairs, which each evaluate to 1. So the answer is 50. So we were asked, what is the difference between the sum of evens between 1 and 101 and the sum of odds between 1 and 100? And we believe the answer is 50. How many 3-digit integers yield a 3-digit integer when divided by 9, then reduced by 9? So we have to run the process backwards. So the lower failure point would be 100. 100 plus 9 is 109, and then multiplied by 9 would be 981. We try it for 101. And 101 plus 9 is 110. And then multiplied by 9 is 990. And then you can try for 102. And you get 111, which increases then to 999. So there are really only 3 integers that satisfy this. 999, 990, 981. So how many 3-digit integers can be divided by 9, then reduced by 9 and give another 3-digit integer? The answer is just 3. how many of the following are integers? There's five that follow. 1 over 1. 11 over 1 plus 1. 111 over 1 plus 1 plus 1. 1111 over 1 plus 1 plus 1 plus 1. And finally, 11,111 over 1 plus 1 plus 1 plus 1 plus 1. The first is an integer. The second is not. The third is an integer, namely 37, but the fourth is not. And the fifth, that's not an integer either, because we'd have to divide it by 5, and it clearly does not end in 5. So only 2 of them are actually integers. So we were asked how many of the following are integers, and we were given 5 possibilities: 1 over 1, 11 over 1 add 1, 111 over 1 add 1 add 1, 1111 over 1 add 1 add 1 add 1, and lastly 11,111 over 1 add 1 add 1 add 1 add 1. And we decided only 2 were integers, the first and the third, evaluating to 1 and 37 respectively. So we are asked, which of the following is false? 12 is a multiple of 2. 123 is a multiple of 3. 1,234 is a multiple of 4. 12,345 is a multiple of 5. Or, finally, 123,456 is a multiple of 6. The first is true, because it's the 6th multiple. So is the second, because it's the 41st multiple. The third is not true. It's not true, because when you divide it by 2, you get 617, which cannot be divided by 2 again. The fourth claim is true because it ends in a 5. And the last claim is true because it's even and the digits add up to a multiple of 3. So which of those claims is false? The answer is the third one. So we were asked which of these is false. 12 is a multiple of 2. 1, 2, 3 of 3, 1, 2, 3, 4 of 4, 1, 2, 3, 4, 5 of 5, or 1, 2, 3, 4, 5, 6 of 6. And we decided it's the claim that 1,234 is a multiple of 4. The digits 1, 2, 3, 5, and 8 fill in box, box, divided by box, take box, equals box. and we are asked what digit immediately follows the division sign. So we have 1, 2, 3, 5, and 8. Okay, so we can't subtract 5 from 1, 2, 3, 5, and 8. The pains of misremembering. So the digits 1, 2, 3, 5, and 8. Fill in box, divided by box, plus box equals box. And we have to find out what digit comes immediately after the division sign. Now 32 divided by 8 is 4. And 1 is 5, so it would be 3. 2 divided by 8 plus 1 equals 5. So what immediately follows the division sign is an 8. Kai swaps half her 2p coins for 10p coins, bringing her total to £4.20. Find her initial total in pounds. Oh. Kai swaps half her 2p totals for 10p totals, bringing her total to £4.20. Find her initial total in pounds. And the answer is £1.40. So Kai swapped half her 2p coins for 10p coins, bringing a total to £4.20, and we have to find the initial amount that they had in pounds, and we believe the answer is £1.40. "48 children have a boy-to-girl ratio of 3 to 5. How many boys must be added to bring the ratio into being 5 to 3? So 48 split into 3 to 5. We can multiply 6 by 3. To get 18. So 18 and 30 are the initial absolute amounts. And then we need it to be in the ratio of 5 to 3. So there'd have to be 50 boys and 30 girls in the new one. And to go from 18 to 50, you have to add on 32. So we're told that for 48 children, they exist in a boys to girls ratio of 3 to 5. And then we're asked, how many boys would actually have to be added to invert the ratio and make it 5 to 3 instead? And we believe that the answer is 32. 32. Which of the following is the largest two-digit integer divisible by its product? 12, 24, 36, 72, and 96. No. Which of the following is the largest Which of the following is the largest two-digit integer divisible by the product of its own digits? We were given 12, 24, 36, 72, and 96. So for 12, it's a yes. For 24, it's a yes. For 36, true. For 72, true. For 96, not so, I'm afraid. So it's 72. A snail slithering at a constant speed has slithered 150 centimeters by 150 p.m. and 210 centimeters by 210 p.m. At what time did it start? So 20 minutes transpired between 1:50 p.m. and 2:10 p.m. And in that time it slithered 60 centimeters, making it 3 centimeters per hour, or rather 3 centimeters per minute. 3 centimeters per minute. And 50 minutes has transpired since it began. So the real answer is 1 p.m. A paint pot weighs 5.8 kilograms when half full and 3.1 kilograms when a quarter full. What is its full weight? So their difference is 2.7 kilograms, and that's a quarter, and therefore its full weight is 10.8 kilograms. So in the previous problem, we were told that a snail has slithered 150 centimeters by 1:50 p.m. and 210 centimeters by 2:10 p.m. and we were asked when did it start, and we believe the answer is 1 p.m. And in the last problem, we were told that a paint pot is 5.8 kilograms when it's half full and 2.1 kilograms when it's a quarter full. So what is its full weight? Yeah, we believed that the answer was 10.4, but that's wrong. Oh, let's correct it. 5.8 kilograms when half full, 3.8 kilograms when a quarter full. Oh, I see. Let's do this again. A paint pot weighs 5.8 kilograms when half full and 3.1 kilograms when a quarter full. Now we must account for the weight of the pot itself. 5.8 take 3.1 is 2.7. So that's the so that's like a quarter of the liquid or whatever it is that fills it. 2.7. Now 2.7 plus 2.7. 2.7 times 4 is 10.8, but then we have to add on the weight of the pot. So we have to do 3.1 take 2.7, so we get 0.4. 0.4 plus 10.8 is 11.2. So we were told that a paint pot is 5.8 kilograms when half full, 3.1 kilograms when a quarter full, and we were asked to find its full weight, and we believe it's 11.2 kilograms. Right, brilliant.